Design and sizing of a photovoltaic (PV) system. Designing and sizing a photovoltaic (PV) system requires careful planning to meet energy needs efficiently. The process includes assessing energy requirements, selecting appropriate components, and ensuring the system's capacity matches the load demand. Below is a step-by-step guide to designing and sizing a PV system. Step 1. Determine energy needs. List electrical appliances. 1. Create a list of all appliances that will be powered by the PV system. 2. Record their power ratings, in watts, and daily usage hours. Calculate daily energy consumption. Energy consumption equals power, W, times hours used per day. Energy consumption equals power, W, times hours used per day. Example 1. Refrigerator. 150 W times 24 hours equals 3,600 watt-hours, 3.6 kilowatt-hours. 2. 5 LED bulbs. 10 W times 5 bulbs times 6 hours equals 300 watt-hours. 3. Total daily consumption equals 3,600 watt-hours plus 300 watt-hours equals 3.9 kilowatt-hours per day. Step 2. Estimate solar panel requirements. Determine solar panel capacity. Consider average sunlight hours available in your location, e.g., 5 hours per day. Divide daily energy consumption by the sunlight hours to calculate the required panel capacity. Panel capacity equals daily energy consumption, WH, sunlight hours, panel capacity, equals daily energy consumption, WH, sunlight hours. Example 1. Panel capacity equals 3,900 watt-hours. 5 hours equals 780 W. Panel capacity equals 3,900 watt-hours. 5 hours equals 780 W. Add a safety margin. 1. Add 20 to 25% to account for energy losses. 1. Total panel capacity equals 780 W times 1.25 equals 975 W. Total panel capacity equals 780 W times 1.25 equals 975 W. Select solar panels. 1. If using 300 W panels, the number of panels required. Number of panels equals 975 W. 300 W equals 4 panels. Number of panels equals 975 W. 300 W equals 4 panels. Step 3. Battery sizing. For off-grid or hybrid systems, determine required battery storage. Decide how many days of autonomy, backup, are needed, e.g., 2 days. Calculate total energy storage required. Battery storage equals daily energy consumption * days of autonomy. Battery storage equals daily energy consumption times days of autonomy. Example 1. Battery storage equals 3,900 watt-hours times 2 equals 7,800 watt-hours. Battery storage equals 3,900 watt-hours times 2 equals 7,800 watt-hours. Choose battery voltage. For a 48 volts system, battery capacity A equals total storage, WH, battery voltage, battery capacity A equals total storage, WH, battery voltage. Example 1. Battery capacity equals 7,800 watt-hours, 48 V equals 162.5 Ah. Select batteries. 1. Using 200 Ah batteries, the number required. Number of batteries equals 162.5 Ah. 200 Ah equals 1 battery. Round it up. Step 4. Inverter sizing. Select inverter capacity. 1. The inverter must handle the maximum load at any given time. 2. Add a 20 to 25% margin for peak loads. 3. For a total load of 1,500 W. Inverter size equals 1,500 W times 1.25 equals 1,875 W. Inverter size equals 1,500 W. 1.25 equals 1,875 W. Choose an inverter. 1. Select an inverter with a capacity equal to or slightly higher than the calculated size. 2. Use a 2 kilowatts inverter in this example. Step 5. Charge controller sizing. Calculate charge controller rating. 1. based on the total solar panel current and system voltage. 1. Charge controller current equals panel power systems voltage, charge controller current. 2. For 975 W panels and a 48 volts system, current equals 975 W, 48 V equals 20.3 A. Select charge controller. 1. Choose an MPPT charge controller rated higher than the calculated current, e.g., 30A. Step 6. Summary of components. 1. Solar panels. 4 times 300 W monocrystalline panels, 1.2 kilowatts total. 2. Batteries. 1 times 48 volts, 200 Ah battery. 3. Inverter. 2 kilowatts inverter. 4. Charge controller. MPPT controller rated at 30A. 5. Mounting structure. Based on roof size and orientation. 6. Wiring and connectors. Copper cables rated for the system voltage and current. System variations. Option 1. Grid-tied system, no batteries. 1. Excludes battery storage. 2. Reduces upfront costs but relies on the grid during outages. Option 2. Off-grid system, with batteries. 1. Includes battery storage for complete independence. 2. Higher initial investment and maintenance costs. Example calculations for 2 scenarios. Scenario 1. Small home system. 1. Daily load, 2 kilowatt-hours per day. 2. System type, off-grid. 3. Components. 3 times 300 W panels. 2 times 12 volts, 200 Ah batteries in series for 24 volts system. 1 kilowatt inverter. 20 AMPPT charge controller. Scenario 2. Medium home system. 1. Daily load, 5 kilowatt-hours per day. 2. System type, hybrid. 3. Components. 6 times 300 W panels. 2 times 48 volts, 200 Ah batteries. 3 kilowatts hybrid inverter. 40 AMPPT charge controller. Considerations for PV system design. 1. Location and climate. Optimize panel tilt angle and orientation for maximum sunlight. 2. Energy efficiency. Use energy-efficient appliances to reduce system size. 3. Future expansion. Design the system to accommodate additional panels or batteries. 4. Budget constraints. Balance between upfront costs and long-term savings. This systematic approach ensures a well-sized and efficient PV system tailored to energy requirements and site conditions.